I'm starting my work on building myself a custom exhaust from scratch. So I thought it's best if I share my whole process starting from the very beginning, including the mistakes that I make and my full learning curve, so that you can have a kind of a contextual framework to kind of understand what a real life experience is for an amateur builder. So this is not exactly a tutorial, it's just what the real thing looks like, at least from my end. So this will be several videos as a series, and I will be doing this in both Sinhalese and English. So for the Sinhalese version, you can click the link below. So the method I'm going to use for my exhaust is the lobster tail or the classic pie cut exhaust system. So like you can see in the examples, it's a system where you can see all of the wells that are really exposed, and the discoloration is visible, and it's more of an art form really, and it is a little complicated, but it really does render a nice looking exhaust. So that's why I thought I'll give it a shot. So let's see how it goes. To start working on an exhaust, the first step is to at least get a rough idea about what your exhaust should look like. So this is basically what I have in mind, fairly simple setup. So this is what I'm kind of aiming for. Once I get an idea about what the exhaust should look like, I basically hold this piece of cardboard against the head, the engine, and kind of get a rough sketch of what the contours should look like. And based on this rough sketch, I take a couple of measurements using a simple ruler and an angle finder, and I then map this onto a better kind of more uniform sketch. And usually the pie cuts are cut at 15-degree angles. So I divide this part which I estimate to need about 210 degrees of turn. I divide that into 15-degree parts, and that gives me an estimate of about 14 pie cuts needed to complete this shape. So this is what I'm going to take onto the table to cut the pieces out. So looking at the material I'm going to use, this is 304 stainless steel 2-inch diameter tubing with a wall thickness of 1.2 millimeter. The surface finish is what is locally known as hairline finish. So if you go to a stainless steel fabricator, you possibly can find the mirror finish tubing, and you can ask them to apply what they call the hairline finish, and that will give you this material. Even though I used 1.2 millimeter wall thickness material here, it would be better if you can find 1.5 or 1.6 millimeter wall thickness tubing for this kind of application. So if I explain the process that I've used to measure the pie cuts and to make sure that I get the right angles and all of that, I basically make two straight lines down the pipe, exactly 180 degrees apart. So how I did that was using this piece of cardboard, a straight edged piece of cardboard, and I basically take a measurement across the entire tube, and I fold it in half exactly in the middle. So where the cut is and where the fold mark is where the 180 degree separation is. So I make a cut down that middle. So I make a marking down the middle using that method, and on my chop saw, on this stationary bracket, I masked it off, and I make a mark exactly halfway up the tube's diameter. So I basically align one of the lines that I made on the tube and make a single cut, and then I rotate the tube until the other line on the tube aligns with the mark I make on the bracket. So it's exactly 180 degrees rotated, and I make the second cut. To determine the length, after cutting out a couple of test pieces, I found out that for this specific chop saw, if I measure 36 millimeters from the end of the bracket to the edge of the tubing, I get the right cut. So that's the measurement I took to make sure that I cut even pieces. So it's super important that you get a clean and very flat cut surface on each of your pie cuts. So I haven't cleaned the inside edge of these pie cuts because these are just a couple of test pieces that I'm trying to weld together, but all of these cut marks have to be taken out, and you can see that on this flat work surface, the actual pie cut pieces sit completely flat. So that means the cut surface is very straight, and that is very important because it will give you an easier time when you try to weld these together. So to weld stainless steel, you will need a TIG setup, basically a tungsten welding plant using argon as the gas. So I use a couple of welding equipment in my shop, and I will do a separate video to kind of run you through what they're used for. So this is the first kind of couple of pieces that I welded together. As you can see, there are a lot of mistakes on this, a lot of undercutting, burn throughs, as in small holes that have been burnt completely through the material, and there are issues with my torch speed. And I also have a couple of things to improve regarding my prep work and how I handle the pieces when they're being welded together. So there's a lot to improve, and but to be honest, I'm quite happy as this is the first piece of thin wall tubing that I've basically ever welded. So I'm quite happy about it as a first attempt, but there's definitely a lot of room to improve. So this is my second kind of attempt to build a wider piece, and I've just stacked this together. So in the next video, I will take you through how I kind of mock this up to the complete full system, and see how it goes from there.